Welcome back. This is Mr. Marshall for Trigonometry College, Year 9 Maths. We are looking at trigonometry. Now, in this unit of work, which is trigonometry, you will need to read through and copy the learning intentions and success criteria into your exercise book. We'll be going through the slides. You will need to pause and take notes in your exercise book and then answer the questions found at the end of each lesson in your books. Questions and answers can be found in your Jack Plus books online. So this is lesson 2 of week 7 and we're looking at trigonometric ratios. Now our learning intentions is we are learning to understand the trigonometric ratios, and our success criteria, you will be successful when you can identify 3 possible side ratios, remember the special names given in each ratio, and calculate the ratios for any right-angled triangle. So here I have my right-angled triangle, and I will go through and label each of the sides based on our reference angle down the bottom here. We have the adjacent, which was next to the angle, the opposite, which was opposite the angle or across from the angle, and hypotenuse, which was across from our right angle, and it is also the longest side. So there are 3 ratios that we want to worry about. The ratios are opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And these form these 3 functions or rules. The first one is sine. So sine of the angle is opposite divided by hypotenuse. Cosine of our angle down here is adjacent divided by hypotenuse, and tangent is the opposite divided by the adjacent angle. Now, to save some space in our textbooks, usually what we write is sine equals O over H, cosine is A over H, and tangent is O over A. And a way to remember this, we have a little mnemonic called SOHCAHTOA. SOHCAHTOA. And this reminds us which sides are matched up with which function. So SO means sine is opposite over hypotenuse. Ka is cosine is adjacent over hypotenuse, and TOA is tangent is opposite over adjacent. Now you would have seen these functions on your calculator, and we're going to be looking a little bit later into how they actually work. Today we're just looking at more of the setting it up and these fractions or these ratios. So here's an example. We have a triangle here, we have our reference angle in the corner there, just theta, and we have 3 sides that have all been measured for us. Now, again, I will have my thinking and my writing here. This is what's going through my brain, and this is what I put on the paper to be assessed by and show my workings. So, first off, I always redraw the triangle. So, and then I label the sides just to make sure I know which side's which. So hypotenuse, adjacent, opposite, because remember we're across from that angle. I then write down the ratios. So sine equals opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent. So, ka, toa. And then I just substitute in those values that I've got there into the correct positions. So sine is opposite over hypotenuse, opposite is 5, hypotenuse 13, so sine of our angle 5 over 13. Cosine is adjacent over hypotenuse, adjacent is 12, hypotenuse is 13, 12 over 13, there's cosine equals 12 over 13. And tangent is opposite over adjacent. Opposite is 5, adjacent is 12, tan is 5 over 12. Now, if these could be simplified, we would simplify them. In this case, we don't have any common factors that we can use to simplify these fractions, so we just leave them as they are. Here's a second worked example, and most of your examples, once we start moving on, are going to look more like this. They're going to have an unknown somewhere in there, and we're going to have to work that out. We will be doing that next lesson. For now, we just need to work out which side goes into which part of the ratios. So we look at this triangle, and again I have my think and I have my right draw. So starting off, as always, I'm going to redraw the triangle and label it. So here's my triangle, the angle's in the corner here, so opposite of that angle, there's the x, and adjacent. Now, using our SOHCAHTOA, our mnemonic, we see that we've got an O and an A. So they're used for TOA. So let's write this ratio. Tan equals opposite over adjacent, or tangent is opposite over adjacent. Now let's substitute in those values. So tan of, my angle is 50, my opposite is x, and my adjacent is 18, x over 18. And that's it. So our exercises for today, for practice level students from chapter 6.4, we'll be doing these questions. Our consolidating students will be doing similar questions, and our master level students will be doing one extra question, question 12. So my reflection, can you write out what the mnemonic SOHCAHTOA stands for? And specifically, what shape is it used for?